on section 39, which is average value of a function and also the mean value theorem for integrals. Okay, so we already had the mean value theorem. Remember that involved the average rate of change, but that was for derivatives, so we're going to have a second one for integrals. I know that's very confusing. All right, so the first thing we're going to talk about is the average value of f of x. So what f of x is a height, right? F of x is the height of a function. So if you had a rectangle, and let's say this rectangle had a height of 7, and it went from 1 to 6, what would the area be in here? Yeah, it'd be 35. Do you guys all see that? What would the average height of that rectangle be? 7, because all of the heights are 7. Does that make sense? That's very easy for you guys to understand. But if you have a function where we don't have the same height going across, so if we just have a generic f of x, and again, I go from 1 to 6 or something like that, a to b. Okay, when I talk about the area inside here, it's an integral. It would be like the integral of f of x from 1 to 6, right? That would be the area that's inside here. If I wanted the average height then, how would I do that? So what did I do in the first one for the rectangle? I said I had an area of 35, and what did I divide by to get a height of 7? Guys, think about it. So if I have an area of 35, what did I divide by to get a height of 7, an average of 7? I divided by what number? 5, right? So where's 5 represented? It's the difference between 6 minus 1, right? Okay, so if I'm trying to get the average height, the average value of a function, what I do is I take the area, so in this case it would have been 1 to 6 f of x dx, and I divide that by the length of the interval. So I divide it by the distance from 1 to 6, so we write it as 1 over 6 minus 1 out front. That would be the average value for our f of x. That would give us our average height. Okay, and that average height would be somewhere in between the highest point and the lowest point. It would be somewhere in here. Right? So you're going to have things that go above it, you're going to have things that go below it, and your average height is going to be somewhere between it. Does that make sense? Okay. All right, so that's the average value of a function. So the average value of a function is, you take the area from a to b, so you do your a to b f of x dx, but then you basically divide by the length of that interval. So if I start at a and I go to b, the length of that interval is b minus a, okay? And if you guys think about just normal numbers, it will make sense. If I go from 2 to 10, do you guys see how that's a distance of 8? 10 minus 2. So we divide by b minus a, so we write 1 over b minus a out front. Easy enough? All right, so here's the tricky part for AP Calc students. This is all over the multiple choice section and actually the free response section. This is a pretty important formula. But students, every time they see the word average, they have it ingrained that it's going to be average rate of change. Do you guys remember average rate of change from the first couple chapters? Average rate of change is slope. Do you guys remember the formula for that? F of b minus f of a all over b minus a. Okay, it's units. If f was in like meters, the average rate of change would be something like meters per second. Okay, it's a rate of change. Does that make sense? Average value, its units are going to be things like meters, right? It's not a rate. It's the original f of x value. Do you guys understand the difference? Okay, so don't get them confused. Average value is an f of x. Average rate of change is kind of like an approximation for f prime. Okay, so if it says find the average value of f of x equals 2 plus x minus x cubed on negative 1 to 5, we just set it up and we're like, okay, well I have 1 over 5 minus a negative 1, the integral from negative 1 to 5, 2 plus x minus x cubed dx. So on your homework, pay attention to the instructions. Sometimes I say you're allowed to use Math 9. Sometimes I say that you're not. Okay, so let's say I say that you can use Math 9. Do you guys all remember how to put this into your calculator? Yeah, so you would do Math 9, and some of your calculators are going to show up where it actually shows the integration symbol, right? But mine shows f in int. So I put in my function, so I do 2 plus x minus x to the 3. And then I have to do a comma x, and then I go from negative 1 to 5. So when I do that, I get negative 132. But I still have that number out front, so don't forget that number out front. So I have 1 over 6 times what was it? Negative 132. So then I basically take that number and I divide by 6. So I get negative 22 as my average value. Easy enough? Just a formula. That's all this is. Okay, but sometimes you need to interpret the situations. So the AP test likes to do things like average temperature of a room over the course of a day or whatever, or average temperature of Indianapolis. I think I have an example of that. And that's the next one. Oh, yeah. So it says, in Indianapolis, the temperature in degrees Fahrenheit after 9 a.m. was modeled by the function T of t equals 50 plus 14 sine of pi t over 12. So do you guys understand why temperature is a sine curve? In the morning it's cold, throughout the day it gets warmer, right? Does that make sense? And then it gets cold at night, and then it gets warmer as it approaches the morning again. All right, so we're going to have our temperature function. And our variable is t in this case, so I'm going to write dt. And I'm going from 9 a.m. to 9 p.m. So would I do 9 to 9? No, right? That's going to give me 0 if I do 9 to 9. So I want to do 0 to 12 because it says t hours after 9 a.m. So this is at time 0 and this is at time 12. Okay, is that my average temperature? Is that how I set it up? Or is that just, what is that? That's not the average temperature, right? So the average value would be the 1 over b minus a. I don't have that 1 over b minus a. I have to do the 1 over 12 minus 0. Otherwise, that's just finding the sum of all the temperatures over those 12 hours, which is crazy. Right? We're not going to do that. All right, so this is going to be average temperature. So we find it, so you can do your math 9. So we're going to do 0 to 12, 50 plus 14 sine of pi t, or pi x, divided by 12. So I have my 1 over 12, and then I have my 706.952 number. And so I have to divide by 12. So I get 58.913. And this is in degrees Fahrenheit. Does that make sense for the average temperature of a city? Yeah, do you know what people do all of the time? They give me this answer here. Like, wow, Indianapolis was 706 degrees Fahrenheit. That's really hot. So think about your answers. So especially on the AP test, they'll do things like that where people will forget the 1 over b minus a out front, and then it will be like, that makes no sense at all. So think about that. The other thing I want to mention is on the AP test, I always write my formula in the simplest way possible, okay? Because as I was writing this down, I almost put a minus here on accident. I almost set it up like this, and that would be incorrect. Okay, I would get no points for the setup because I messed up and put a minus. Okay, so it's a plus. So the easiest way to do this would be the 1 minus 12, or 1 over 12 minus 0, going from 0 to 12, and I would write t of t dt, because t of t was already defined in the function. Okay, so always write it that way. You would get a point for your setup and then a point for your answer. Okay?
So you have to do the t, like where it's a t, and then substitute for a point. It's like you can't just write 1 over t minus 0, then summation sign, whatever that is, 50 plus 14 sign. You have to do.
I would do it the easiest way possible, just because I think you're stressed on the AP exam when people make simple mistakes. It happens all the time. Like, I see it on the tests all the time, and I still count it right for you guys. I really shouldn't. I should grade you like you would on the AP test, but I have a soul, so. All right. So question. So for the continuous function f on the interval a to b, will there always be a value c where f of c is equal to the average value? Okay. So do you guys understand what that's saying? So if I have a function, and I'm on a to b, where do you guys think the average height is? I don't know. So there's some place in between the highest and the lowest point, right? So there's an average height in there somewhere. I don't know, somewhere in here. Would there have to be a place between a and b that makes that happen? Yeah. If you're talking about the highest point on this interval and the lowest point on that interval, does there have to be an average somewhere between them that you go through. Yeah, if it's a continuous function, you have to go through that height. Okay? That's basically the mean value theorem for integrals. So do you guys remember the mean value theorem for derivatives? It was if you had a and b and you have some kind of function and you connect them and you have a slope, do you have to have a slope, the same slope between those? Yeah. And that was the example that I gave you where it was like you're driving 120 miles and it takes you 2 hours. Do you have to go through 60 miles per hour at least once? Yeah, you do, right? Because you can go, faster than that and slower than that. You're going to have to go through 60 miles per hour. This is the same idea. Do you guys understand how that's the same? Because you're saying there's a highest point and there's a lowest point. Do you have to go through the medium point at least once? Yeah, you do. All right, so that's the mean value theorem for integrals. So it basically says that the average value is equal to some y value. So some y value is equal to the average value. That's how we set it up. And then sometimes you'll see people multiply the b minus a over. It's exactly the same formula. So let's try this one. So it says find the average value of f of x equals x minus 3 squared on the interval 2 to 5. So that's the first part of the problem. So we're going to say, okay, I'm going from 2 to 5, my f of x function. So the simplest way to write this would be like that. Do you guys see how I just put f of x there? Well, I guess I could put a dx as well. They won't count you off if you forget the dx. No worries. That doesn't mean just stop writing it. All right, so we have that. Now we could do this one by hand. We could FOIL it out and do the antiderivative, right? But now that you've learned the glory of Math 9, I know you guys want to do that. Yes, that means integral, integrate, which is an antiderivative, the opposite of derivatives. So I get 1/3 times, and when I integrated this, the integral from x minus 3 squared from 2 to 5, I ended up getting 3. Did you guys get that? So we have 1. How very nice. Nice and clean. It's not always that clean. All right, so is there a value c such that f of c is equal to this? Well, this was the average value, right? So we just found the average value was 1. So we set it equal to our f of c, or f of x. I usually just do f of x. So I do x minus 3 squared equals 1. So we're find a value for x that has this average height. That's what we're doing. Do you guys understand that? Okay, we just solve it out. So I see a lot of you guys do like things that take longer than they should take on things like tests. This was an example. There was an example like this on a test earlier in the year. And a lot of you guys like FOILed it out, which is fine, like you got there. But you guys don't have to FOIL things out and say, oh, x squared minus 6x plus 9 equals 1. Subtract the 1 over, factor, right? What can you do? Yeah, you just kind of take the square root. And some of you guys are saying, oh, it has to be 4, right? 4 minus 3 squared gives me 1. And 2 minus 3 would be negative 1 squared gives me 1 as well. So you don't waste a lot of time on simple steps like this. You guys know these steps. So you get x minus 3 equals plus or minus 1. So we do get 4 and 2. Because we'd have 1 plus 3 and we'd have negative 1 plus 3. All right, so are both of those on the interval? Just one of them on the interval? Both of them, right? So I would say both 4 and 2. There's 2 places where you go through that average height, basically. So, yeah, those are the x values. So the average height is 1. So it's basically like if you had an average height of 1, maybe you have it go through at 2 and also 4, like that.
But right,
Makes sense.
but right, if like let's say one of those was out of the interval.
If one of them was out of the interval, we don't include it in the answer. All right, so find the numbers b such that the average value on the interval 0 to b is equal to 3. Okay, a little bit harder. Okay, so let's think about what it's saying. So the average value on the interval 0 to b. Yeah, we're going to do 0 to b, and we're going to have this f of x function. And then we're going to have 1 over b minus 0. All of that has to equal 3. So we have 1 over b, the integral from 0 to b of 2 plus 6x minus 3x squared dx has to equal 3. Okay. So our calculator can't handle that. It can't do 0 to b. Like, what's b, right? So we're going to do it by hand. So I'm going to have 1 over b, and I'm going to integrate, and I have 2x plus, see, I'm going to have an x squared. What number will I have in front of the x squared? 3, right? Because it'd be 6 divided by 2. Minus x cubed. What number am I going to have in front? 1, yep. Going from 0 to b. Don't need a plus c this time. Why? It's a definite integral. Right? Basically, if you had a plus c, so this is the day that I was sick. I didn't get to tell you all this. If you had a plus c, and then you go from 0 to b, do you guys see how you would plug in the b? You guys don't have to write this. I'm just kind of writing it quickly. And then you'd plug in the 0. 0 plus 0 plus 0 plus c. Do you guys see how the c's would go away? You'd have c and then minus c. It would all go away. So we just don't put c's on the definite integral. It's kind of assumed that it's there, but we just don't write it. Okay? Meredith, you with me? She looks like she's dying. You guys are so ready for this long weekend. But it's only Monday, so you got to power through the rest of this week. You have Friday and Monday off. All right, here we go. So we're going to put the b in. So I have 2b plus 3b squared minus b cubed. And then the second part of that was all 0. We like when it's like 0 to b on polynomials, right? And then equals 3. So if I multiply this 1 over b in, I get 2 plus 3b minus b squared equals 3. And we can solve it. I get everything on one side, so I'm going to add the b squared over, subtract the 3b, subtract the 2, and then I can factor if possible, which is not. So we do the quadratic formula. I know, I love hearing all the complaints on quadratic formula. This is the easiest thing you guys do. All right, negative b plus or minus b squared minus 4ac all over 2a. So we get 3 plus or minus the square root of 5 all over 2. And we're on the interval 0 to b. So let's just make sure that both of these are positive, because we started at 0, right? What do you guys think square root of 5 is? Is it bigger than 3 or smaller? It's smaller. It's like 2 point something, right? So we have 3 minus 2 point something. That's okay. That's positive. Both of these could be answers then. Does that make sense? Mm-hmm. That would be definitely like a free response type question. You guys can handle those. Mm-hmm. Yeah. Like if it had been like 3 plus or minus the square root of 11, I would just write the 3 plus the square root of 11. All right, is that it? That's all for this section? Man, you guys are lucky. All right.